In this video, we are going to be calculating the stairwell openings on a set of winder stairs. This is a companion for the modules for a level 4 carpentry apprenticeship for H-line, H5. Not a difficult calculation. It helps to have a good knowledge of level 2 calculating stairwell openings for an L-shaped stair. It's basically the same calculation with just a few wrinkles added in. So this is just a basic example here. In this case, we have all sorts of givens. Many times we don't have a unit rise established, and we need to establish that unit rise. But in this case, it's been given to us as is the run. So if you weren't provided with these, then you would have to calculate that. And from that we get the number of risers and the number of treads always being one less than the number of risers. And one last little bit of information we usually get in these problems is the number of treads. In this case, we're given a number of treads in the upper straight run, so that would be right here. Sometimes you'll be given it in the lower and have to figure out what you have in the upper. We need that number to calculate several things. Let's just move forward. Let's finish reading these out too. We have the headroom required in this case would be 2,000 millimeters, and we have a floor frame thickness of 217 millimeters. Okay, and we have a bit of an answer key here. Really walking you through the steps. This just repeats what I just mentioned. Usually you need to find the true rise, number of risers, number of treads. In this example, they are given to you. So we jump straight to calculating the stairwell openings. So your first move when calculating stairwell openings for a set of winders is actually to establish if there is going to be a stairwell B, or if you can frame off that opening in that first flight before the stairs turn. This is the same type of thing you would determine on a set of L-shaped and U-shaped stairs, a similar process. So what we're going to do is we're going to take the total vertical amount we need to meet code. We're going to use that headroom requirement and a floor frame and get a total of 2,217. Okay, the next move is to take the total vertical amount in stairwell A as if you were, it says here taken from the bottom winder to the top. So it's as if you were standing on the bottom winder. So if we look at the picture, you have your feet on this winder. Everything below you is a part of the straight stairs going down. And you turn around and everything above you, which would be the two rises in the set of winders plus all the rises above the winders, is the vertical amount in stairwell A. So we just count these off. Each line representing a rise. So we have, standing here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We also know that each one of those rises is 183 millimeters. So we're going to put those two numbers together, and that happens here. 9 times 183 is 1,647. So what we just determined is that the vertical distance in that upper stairwell is not enough for us to frame off the floor above, because we didn't reach this number here. That tells us there will be a stairwell B, and that's kind of what we're going through here. We also need to calculate the difference between these two. That's what I'm doing here, subtracting that vertical amount in stairwell A from our total required vertical height, which would be the headroom plus the floor frame. And what's left over in this situation is 570 millimeters. That means we need to descend the stairs from this point down a vertical amount of 570 millimeters before we can frame off the floor above. Okay. So we'll get to that. We'll use that information when we calculate stairwell B. So to calculate stairwell A, all we're going to do is add up the horizontal amounts along the run. Let's just take a look at the visual again. So it's this distance here, and it's compiled of 1, 2, 3, 4, 5, 6 unit runs of 267. It's also the width of the stairs, which in this case is 860. And there's this little amount here that you have to factor in when you're dealing with winder stairs. And what that is actually the offset of the angle here that gives us the minimum tread depth at the inside of the stairs. So on a set of winders, a set of 3 winders, on a set of any winders, we need 150 millimeter minimum tread depth here. And I'll just jump over to a better visual of that. So if this is that bottom winder, each winder, on a set of 3 winders, are turning 90 degrees. We've got 3 winders, so each winder turns 30 degrees. And if we have 150 millimeters for the tread at the inside, this offset distance has to be, and it'll be 260 millimeters. It's based on the trigonometric ratio of the 30 degree angle and the 150 millimeter minimum. So that on a set of 30 degree winders, that's always 260 millimeter offset. On a set of 40 degree or 45 degree winders, so a set of 2, 90 degrees broken up in half, that offset would be 150, because the angle is now 45 degrees, and we're still trying to achieve 150 on the minimum run. And if that angle is 45 degrees, then it'll be 150 millimeters also on that offset. But in this case, we have a set of 3 winders, and we're using the 30 degree turn, which means we are using the 260 millimeter offset. So that's the amount for that final piece of the puzzle to figure out stairwell A. Let's jump to the math here. Stairwell A, here you have it all written out. 6 treads at 267 mil, plus the 260 offset, plus the width of the stairs, which in this case is 860, giving us 2,722. Remember, when you're doing these calculations, that is a finished opening, and we will always add 75 millimeters to that to make it a rough opening, to give us a bit of wiggle room for whatever might be used to finish that stairwell. Okay, and that helps keep us within code. Okay, stairwell B. Again, much the same as doing an L-shaped stairwell opening. We are going to use that vertical amount that was left over. I mentioned earlier, it was 570. That's the vertical amount remaining before we meet code, and we are able to frame in above. And we are going to determine a horizontal distance based on a ratio and proportioning against the slope of the stairs, which is the rise and run. This is the unit rise and unit run. Okay, so based on a ratio and proportioning, we can solve for x, cross multiply these two, and divide by 183. We get 831.6 millimeters. So that tells us that to descend 500 and whatever it was, 70 millimeters to get us to code, we will need to travel horizontally 870, what was that? 831, sorry. Okay, and then all we need to do, now that we have a horizontal distance, all we need to do is add the offset and the stair width to that. So we just determined this horizontal distance, and we're just going to add the width of stairs and the offset to that, and then we get that stairwell open. And let's take a look at the numbers. And here you have it, 831.6 plus 260 plus the 860. Gives us 1951.6, and then don't forget to add 75 millimeters. And there's your rough opening for stairwell B. So that's calculating a set of winder stairwell openings. Not the most practical application. You don't see winders as often as you used to, because if you can imagine, if you're aware that the minimum code for a set of straight stairs is 255, and that offset is 260. It doesn't make much sense to make them into winders if you can just put a straight stair there and a straight stair there and make up those 2 rises. So just thought I'd add that in. Less practical than they once were, but that's how you do the math.